Welcome to The Explainer. Today, we're diving into this incredible industrial process. It's literally the foundation of our modern world, but I bet most of you have never even heard its name. We're talking about comminution.
All right, let's just jump right in. Picture this. You've got a whole mountain of solid rock. I mean, just tons and tons of it. And somewhere inside, there are these tiny, microscopic specks of valuable stuff, like copper or gold. So the big question is, how on earth do you get them out?
Well, the answer begins with this word, comminution. It sounds complicated, right? But at its heart, it's all about one thing, breaking stuff down. It's the absolutely critical first step to get those valuable minerals away from all the worthless rock they're trapped in.
Now, you might be thinking, okay, so you just smash rocks. But it's way more sophisticated than that. This isn't just about brute force. It's a super precise two-step procedure that takes these giant boulders and turns them into a really fine, carefully controlled powder. So, first up is crushing. We're talking about massive machines that take these huge chunks of ore and just crunch them down into something more manageable. Then, once you have those smaller pieces, they go into the next phase, grinding. They're fed into these enormous rotating mills that just tumble and grind them down into that super fine powder we were talking about.
Okay, and this is where it gets really, really interesting. The success of the whole darn operation, it all comes down to this. It's what I like to call the Goldilocks problem. The particles can't be too coarse, they can't be too fine, they have to be, you guessed it, just right.
So why is that size so critical? Well, think about it. If you don't grind it down enough, the good stuff, the valuable minerals, are still trapped inside the worthless rock. You can't get to them. But if you go too far and grind it too fine, you get these ultra-tiny particles they call slimes. And trust me, these things are a total nightmare. They're hard to handle, they waste minerals, and they drive up costs like crazy.
So it's all about finding that perfect sweet spot. The goal is to liberate the valuable mineral from the waste rock, which has a great name, by the way. It's called gangue, but you have to do it without totally pulverizing the mineral itself. It's this delicate dance, really, between breaking it free and keeping it intact.
Okay, so we've got our perfectly sized particles. Now what? Well, let's see how that pays off in the very next stage, which is a super clever process called flotation. And I'm telling you, this is where that just right particle size becomes everything.
So, what is flotation? It sounds crazy, but you literally use bubbles to separate the minerals from the waste. Here's how it works. They add special chemicals to a big tank of water and ground up ore. These chemicals make only the good stuff, the valuable minerals, hate water. Then they pump air bubbles through the whole mix, and since the mineral particles hate water, they grab onto the air bubbles and float right up to the surface. You can just skim them off the top. It's genius. But, and this is the key, none of it works if the particles aren't the right size.
Yeah, that particle size, it controls everything at the stage. First, it determines if the mineral is even free to be grabbed in the first place. Second, the particle has to be small enough for a tiny air bubble to actually lift it, but not so small that it just gets washed away in the water. It also affects how well those special chemicals can attach to the surface. And all of this, it directly impacts how much you recover and how pure your final product is. It's the whole shebang.
And this chart just lays it all out perfectly, doesn't it? Look, if your particles are too coarse, you lose. Recovery is low. Grade is low. Too fine? Same problem. Recovery drops, costs go way up. The whole operation has to live right there in that optimal sweet spot. That's where you get high recovery, high grade, and you do it all efficiently.
And believe me, the consequences of getting this grind wrong don't just stop at the flotation tank. Oh no, the ripple effects are huge, hitting both the company's bank account and the environment.
Let's talk about overgrinding, or grinding things too fine. It is just incredibly wasteful. For one, it burns through a ridiculous amount of energy, and energy is one of the biggest costs in any mining operation, period. On top of that, you're using up more expensive chemical reagents, and you're literally wearing down your multi-million-dollar equipment faster. It's just losing on all fronts.
So when you boil it all down, this is the name of the game. A perfectly optimized comminution process is what separates success from failure. It's the thing that makes sure all those valuable minerals, the reason you're doing all this in the first place, end up where they belong, in the final product, not in the waste pile which they call tailings.
So it turns out comminution isn't just about smashing rocks with brute force, is it? It's really about incredible precision. It shows us that sometimes the biggest challenge isn't just figuring out how to break things, but having the wisdom to know exactly when to stop. Makes you wonder, what other parts of our world depend on finding that perfect, delicate balance?